Welcome back, everybody. In this video I'm going to show you how to graph these functions and a couple of tricks that might be helpful to be able to calculate any log function by mental math. So really fast I will show the visualization of these graphs so that you can understand the behavior of these functions over time and be able to picture it. So this is an exponential function here, and I'll show what different exponential functions look like. Here I'll show a few examples of exponential functions, but first let's graph y equals 1 to the x. And so if you see this, it's a horizontal line from negative infinity to positive infinity, because no matter what the x value is, our y value will always be equal to 1. So for x value is 0, it'll be 1. For x value is a negative number, it'll still be equal to 1. For x value is a positive number, it'll still be equal to 1. But let's say we next graph our first example of an exponential growth function, y equals 2 to the x. And you can see the exponential growth is coming in from negative infinity here, and then it goes up and at an exponential increase. Now, if we keep on increasing the amount of exponential growth, you can see how how it approaches this, how it gets closer and closer to here, and that point is always fixed. And what point is that? The point is 0, 1, because no matter what, if x is 0, y will be equal to 1. But let's just go like 100,000 to the x. And so you can see it's getting closer. This is getting closer and closer to the y-axis. And so let's say let's go crazy here and put a lot of zeros. You can see it's never really touching here. So let's just remove some of these so you can see them. And so even at such a large value, you can see it's never really touching 0, 0. No matter what, it doesn't touch 0, 0. It's asymptotically approaching it, and it reaches that point 0, 1 because it has to reach that point no matter what. So as long as you increase the number of zeros, you're just increasing, and it never touches 0, 0. No matter how many zeros we put, it's getting closer and closer to it, but it's never going to touch 0, 0 because it has to reach that point 0, 1. But anything exponential to the 0 power, it'll equal 1. It won't touch 0, 0. It won't touch the origin. So that's how exponential growth functions work. And it's useful to know that because you can see the difference between y equals 2 to the x, and you know that's an exponential growth function. But if you go y equals 10 to the x, you can see that growth rate, how it's a little bit increased, and it's a more exponential increased growth function. And so you can kind of see the differences in graphs here. Next, let's graph y equals log x. And you can see that is actually an inverse of y equals 10 to the x. Let's do something. Let's graph y equals 10 to the y. See, that's the exact same thing as log of x. So y equals 10x is really x equals log y. And x equals 10 to the y is really y equals log x. And so you can see how they're inverses of each other. So if we graph it in log form, you know, this is literally the same thing as y equals 10 to the x. It's an exponential function, and this is the same thing as the inverse of that, which is why it's flipped. And so that's equivalent. So it's helpful to visualize these graphs. And for the log x graph here, or the x equals 10 to the y graph, we can see a point on there is 1, 0. So on the exponential graph, we always have 0, 1. On the log graph, because we're kind of reversing the variables here, we have 1, 0. So first, just to get some practice going from 10 to the x equals y to going to the log form. So for example, let's say we have 10 to the third is equal to 1,000. Again, how do we convert that to the log? We just do log of 1,000 is equal to 3. Similarly, if we have anything 10 to the x is equal to y, we would just, this would be our power, right? So we would just be, and that's our base, so we would just be log of y is equal to x. So that's exactly what we have here. When we're going from this exponential function, y equals 10 to the x, we're just taking log of y is equal to x. So log of y is equal to x, and that's the function that we have here. So these are equivalent functions. Y equals 10 to the x is an exponential function. X equals log y, that is the same exponential function. However, what we usually are looking at is y equals log x. So that's the inverse of y equals 10 to the x. So if we reverse y equals 10 to the x, and rather now we have x equals 10y. Sorry about that. Now we have x equals 10y. Now again, this is y equals log x. So these two are the same, and then these two are the same. So on the log x graph, on the log y equals x graph, so this is basically 10 to the x equals y. It's an exponential function, and 0, 1 is always a fixed point on that graph. And 0, 1 again is a fixed point on any exponential increase graph like this. But the inverse of that, 10 to the y equals x, we basically have y equals log x. And it's useful to note this graph here because you can see it's that 1, 0 is a fixed point, and that it's increasing like this, and it's the behavior of the function over time as y equals 10 to the log x graph, as a y equals log x graph. So excuse my drawing of the y equals log x graph. In the previous one, I had this touching the y inner axis, but it should not be touching the y-axis because it's just flipped of the y equals 10 to the x. It's flipped across this y equals x line, just like how the y equals 10 to the x line doesn't touch the x-axis. The y equals log x, the 10 to the y equals x graph should not be touching the y-axis. And also, if you think about it, log of 0 is undefined, so you can't raise a base to any power and get 0 as the result. So This should not touch the y-axis, it should be flipped like this. For the y equals log x graph, aka the 10 to the y equals x graph, there's no power if x is equal to 0 that you could raise the base to be able to make that true, which is why it's undefined. So for the y equals 10 to the x exponential graph, you have a y-intercept, and for the inverse graph for y equals log x, or aka 10 to the y equals x, you actually have an x-intercept. So just remember the y equals log x and the exponential graphs. So I hope that was helpful on how to visualize these functions and graphs. In the next video I'll show some tricks and how to do these calculations with mental math.